This one you know how to do most of it. We're just going to pick up little things that are more for the algebra student that maybe you didn't do in algebra. So we're going to look at solving inequalities, first of all with one variable, and that's what the warm-up was. So I know you had to know how to do all this. Inequalities have less than, equal, greater than equal, right? Solutions to inequalities are values that make the inequality true. So if you say x is less than 1, what's the solution to x is less than 1? 0, because it's less than 1. What's another one? Negative 1, right. So is 2 a solution? No. Has to be less. Is 1 a solution? No. How many solutions are there? Infinite number. So to find the solutions to inequalities, we do what we do with equations. But instead of using the axioms of equality, we're going to use the axioms of inequality, and they are very similar to what you saw with equations. Transitive property of inequality. We had this in equations. If A equals B, and B equals C, and A equals C. So the same is true with an inequality. If A is less than B, and B is less than C, then A is less than C. Now you can put in any inequality symbol here, and it's still going to be true. Put in all greater than, less than equals, it's still going to be true. Addition property of inequality. Well, the addition property of equality was if you add the same thing to equals, it's still equal. Well, this says if you add the same thing to an inequality, it's still that same inequality relationship. So if A is less than B, and you add C to both sides, right? C would be the same number, then it's still that same inequality. And we have the multiplication or subtraction property. You can subtract the same thing from an inequality, it's still the same inequality. Multiplication property and division are very similar, but there's one difference. So let's see if we can figure this out. If A is less than B, and you have a number that's bigger than 0, then AC less than BC, right? You just multiply it, it's still less than. However, if C is less than 0, what does that mean? It's a negative number. If you multiply both sides by a negative, see how this less than turns into a greater than? That's the flip sign thing. And it's the same thing with division. So if it's greater than 0, you just do what you do. The less than, less than. Or if it's a greater than, it stays greater than. But if it is a negative number, then you are turning that symbol around. Okay, that's the only difference. Axioms of inequality. So we can justify steps with this too. Right, this just means that these were all greater than it works. Which axioms of inequality do you look here and do we not see that we have with equality? There are a couple of axioms of equality that are not here as axioms of inequality. Do you know which ones they are? Can you find them? Do you remember what they are? Let me help you out here. What's the reflexive property of equality? Of equality now. That's the one that says if you have a number, it equals itself. A equals A. That's reflexive.
That's what I was going to say.
Good. It is like a reflection. It's like you're looking at yourself in the mirror there. Does it work for inequalities? Let's try it. A less than, no. So it's not here. There's another one that's not here. It's called the symmetric property of equality. Remember what that thing is?
Opposite A.
Yeah. So if A equals B, then B equals A. Is that true with inequalities? If A is less than B, is B less than A? No. Well, yeah. So we don't have that up there. Right? So there are a couple of them that don't actually work for inequality. Okay. What else we got here? Okay, and what's different about the multiplication division properties of inequality? When you multiply, and you might want to write this down here. There's a little blank for you. Okay, see the middle of the page there? When you multiply or divide by a negative number, you're going to turn the inequality symbol. And what I mean by that is if you have a less than, and then you multiply both sides by a negative, you're going to get a greater than. And if you have a greater than, and you divide both sides by a negative, it turns into a less than. Right? So So make sure you got that in there, big letters. That is the most common mistake. You forget to do that or you do it in the wrong place. Only if it's a negative. If you're multiplying by positives, don't change that symbol. Just leave it. Yes?
If this top number is negative, the bottom number is positive.
It's whatever you are multiplying both sides by. Doesn't matter what the number, like, we had an example like this, so, I think what's it 2y less than negative 8 or something like that? What are you gonna divide by? You turn the symbol? No. Only if you divide or multiply by a negative. Okay. So what's different about solving inequalities? Nothing really, except for that multiplication and division. So I'm going to show you how you do these with the property of inequalities. These are kind of written in your paper there. If x minus 5 were in it, they want you to solve that. I'm going to call that the given thing. So you are going to add 5 to both sides, right? Who says you can add 5 to both sides? The addition property of inequality. And then we simplify that out. Now look what I did here. What's this thing? What's that called? Set builder notation. It's an inequality. You can build a set of solutions because how many solutions are there to x bigger than 2? Infinite. So we're writing it using set builder notation. We're building a set of infinite numbers there. There are an infinite number of solutions for that. Okay? Multiplying, dividing by a negative. Find the solutions to this. Okay, this one's on here. So there's my given. I got a whole bunch of stuff here. So let's see what I'm doing here. The first thing I'm doing is I'm adding 7 to both sides, right? Who says? Addition property of inequality. Simplify that out, right? That becomes a 15. That's my 0. Then I am dividing both sides by negative 3 using the division property of equality. Now, whenever you multiply or divide, anytime doing an inequality, I want you to pause and stop and think. See this question mark? Do you change the symbol?
Yeah.
Why?
Because
You're dividing by a negative. Dividing by a negative. So see this bigger than? Became a less than. Okay, we don't express inequalities like this. We always put the variable on that left side. So do that. This is not the symmetric property of inequality. I'm not changing anything. If you read backwards, x is bigger than negative 5, and I'm just writing it that way. X is bigger than negative 5. Here's what it looks like in set builder notation. Remember how easy it is to do set builder notation? You put the little brackets, you declare your x as a real number, you put that line, and that's all that is. Yeah. Okay? All right, so I'm just really stressing this. Whenever you multiply or divide, please stop for a second. Am I multiplying or dividing by a negative? If yes, reverse that symbol. You're going to really have to think about that because you might forget. Always put the variable on the left side. That's this step to this step. Kind of turn it around and then put it in set builder notation. Checking is a little bit trickier with this. What you do is you say x is bigger than negative 5. Pick an x bigger than negative 5. You try to pick an easy one.
500.
Negative 4, 500. I might pick 0. Is 0 bigger than negative 5?
Yes.
That's an easy one, right? Because if I plug in 0 here, is 8 bigger than negative 7? Yes, good. I think I got the right. You're right. So it's just trying to check, do I have my sign in the right place? So it's a little harder to check than the equation, but you can. Why do we multiply or divide by negative? Anybody ever explain that to you? Anybody ever explain to you why you flip it if you multiply or divide by a negative? No? See what thinking. Look at us thinking. So, when you multiply by a negative number, we're changing the idea of big and small. What? All right, let's look at this. So, 5 greater than 3, true or false? 5 greater than 3. True. Would you rather have $5 or $3? $5, right? It's bigger. Okay, so I'm going to multiply both sides by negative 1, right? Negative 5 and negative 3. Is negative 5 bigger than negative 3? No. It's less than. When you multiply by, what's happening? Yeah. What's really going on here is if you think about the number line, when you have 5 and 3, 5 is bigger than 3. But that 5, when you go to the other side, this is a smaller number than that one. So when you multiply by negatives, you're kind of flipping from one side of the number line to the other. When it's positive, 5 is big compared to the others. If you're negative, 5 is small compared to these. So it's kind of a little bit of a mind-blowing thing. But if you think of this example, it might help you remember why I need to turn that symbol. Yeah. So it's like, okay, like that. Question? No. All right, so I just a little food for thought. Okay, so you know what? I'm going to leave these U-trays for now. I think when we did the warm-up, you guys are showing me how to get this.
Yeah, I
I'm
get it.
going
This
to
is
leave this
easy.
for now. Graphing, I think you get this too.
Yeah.
X bigger
Yeah.
than 2, right? Remember we do this? What is this? Yeah, you're going to open a circle. Do I close it? No. Do I fill it in? No. These are called holes in graphs. So I don't know if you heard the name before. So if you have an open circle in any graph, even just a number line, it's called a hole. And X is bigger than that. Why can't I express X bigger than 2 as this? Take 3, color it in, and do that. Why can't I just do that? Why not?
Because if the line is like under the, then you might be able to include the.
Well, no, X bigger than 2, is this an equivalent graph?
No.
Okay,
No.
well,
Is that?
yes?
Because it's not greater than or equal to. It's just greater than.
Well, but X bigger than 2, this is one way to graph it. Can I graph it like this?
Yes.
Oh.
Yeah. Because it can be 2.1. No.
What's the matter? It could be 2.1. Is 2.1 bigger than 2?
Yes.
Does this show 2.1?
No.
So be careful. What this says is any number, 2.1, 2.25, 673. Yeah, anything bigger than 2 works. So you have to kind of get out of that integer mindset. We're talking about all real numbers. So the 2 can't be it, but even if you're just a smidge bigger than 2, you work. So that says that you can cruise along the number line here, but as soon as you get to 2, you're falling into a black hole. Because 2 is not bigger than 2. So 2.001 is, so that one's okay. So don't fall into this mistake. I see a lot of people doing that. So closed circle is when it is included. So that would be X bigger than 2 or equal to. You would close up that hole because it counts. It is a solution. All right, I think you did that too. Should we do this one real quick? If we can. Negative 10x. So I'm going to justify steps because that's kind of the new bit. So how do I get there? I'm going to subtract 6x, right? Well, who says you can subtract 6x? Subtraction property of inequality. Okay, and then I want x by itself. So what I'm going to do here. How do I get x by itself? Again, if you solve an equation, what happens? We've got to solve an equation. What do? You divide by negative 16, right? But wait a second. This is an inequality. You have to pause and think whenever you do a multiplication or divide. Did I just divide by a negative? Yes, I did. Turn it. Then go on your merry way. What's negative 8 over negative 16? What happens? 1/2. Who says you can divide by negative 16 on both sides and you have to turn the symbol? Who says it? Division property of inequality. Easy. Now if I want to graph this, I'm like, whoa. So 1/2, that's over here someplace. I kind of have to like put it in. And I circle it. So I fill in this hole. Yes. Yes, because 1/2 is a solution. 1/2 less than equal 1/2. Is that true? Yeah. Equal. And then where am I putting the arrow? Where the less than are, right? Who gets it? Who has a question? Because I am going to leave this. I think you guys get this. There are some U-tries. You know what? Yeah, give it a shot. I just want to make sure we are good. Just give these a shot. Let's see. That's what I got. That's what I got. What do you guys think? Set builder notation. See? Use set builder notation for solutions. Doesn't say there, it says it up there.
You have to do about the test.
Yes. Why are we so terrible about it?
No, really, just terrible. It's just.
Yes. All right. Did we get this or not get this? How about what's the different way? Yeah, but I'm doing that. Just Eddie. Did you get it? You start everything? Alright, this one you're multiplying both sides by -2. Whoa, stop! I multiplied by negative. Turn it. X bigger than -4. Step builder notation. There it is. You go to, here's a -4. Fill in that hole. It's that way. This one, combine your like terms. 5 x's minus 8 x's. How many x's there? -3x minus 4. And I forgot to justify my steps. This one was the multiplication property of inequality, right? Okay, this one I'm basically just combining like terms, simplifying. Okay, now what? Let's subtract x from both sides. -4x minus 4. Who says?
Addition.
What are you doing?
Subtraction property.
You're subtracting. Subtraction property of inequality. Alright, I think I'll add 4 to both sides. How about that?
Addition property of equality. Inequality.
Less than 0, right? Did that get anybody upset?
Oh, I did something else.
I got greater than.
It doesn't?
Yeah.
I got greater than. Yeah, it does.
Wait, how do you get greater than? All I'm doing is adding 4 to both sides. The subtraction property of inequality says you just add 4 to both sides, your inequality stays the same. Then what do I do?
Division property.
Divide by -4. I'm dividing and I'm going to pause and I'm going to ask that question. Did I just divide by a negative number? Did I?
Yep.
Yes. Turn the symbol. That's the division property of inequality telling me to do these things. So -4, that's x. What's 0 for -4? 0. I guess x is bigger than 0. Put it in my set builder notation. Now look, this is an open. Got a hole right there because x can't be 0, but it can be anything bigger. Like 0.00001. So I want to make sure I have all those solutions in there. What? It's greater than.
Oh, here am I.
Greater than, right? All the numbers bigger than 0 are that way. No. This is just like the, a little appetizer.
And
Little
then
review. So, are we back to kind of remembering how to solve just inequalities in one variable, graphing on a number line? Raise your hands. Yeah.
Wait.
Now, if your hand's not up, I'm going to be asking you wait.
Yeah,
Everybody hear the question? Because everybody's like, I put my hand up. The question is, are we back? Do we remember how to solve an inequality with one variable, graph on a number line? No? You don't know how to do that? Okay. Because here comes the fun part now. The fun part. Get to the meat and potatoes now. We just did the little appetizer. So we're going to be working with linear inequalities in 2 variables, just like we did linear equations in 2 variables. So inequalities. All right, so this is what we just did. X plus 7 is less than 10, right? You do -7, subtraction property of inequality, right? And then you find 3. I circle it, I fill it in less than, right? X minus x, so now I'm going to subtract 10. Not on your paper, we're just kind of reviewing, right? Subtraction property of inequality. And then what happens? Divide by -1, so what's going to happen? I'm going to multiply by -1. I'm going to use the multiplication property of inequality. And so you can, and you're going to get the same result. X less than 6. So you find 6, circle it. Do I fill this hole in? Nope. Less than. Where are the less than? This way. That's how we solve one variable. So now we're going to look at 2 variables. Linear equation. Let's just remind ourselves what that is. Y equals 2x plus 3. Now I think we may have lost what goes on with these. Y equals 2x plus 3. It looks something like this. What are all these points on the line representing here? Solutions to this. These are the xy pairs that when you substitute in, you get a true statement. So it's a picture of all the solutions. Because how many solutions are there? Infinite number. So this is a picture of those solutions. Okay? So they're ordered pairs, x y, and they make the equation true. All the solutions when you graph them make this line. We had a couple of ways of graphing. We used table of values method. Remember that thing, a little t-table? Is there -2? Remember this thing? You plug in. We did the intercept method. You find the x-intercept by setting y equals to 0 and solving for x. And the y, right? Oh, you said it. Remember this? Look up x0. And this one's 0y, right? Slope intercept, y equals mx plus b. And we have not done that yet, so don't worry about that yet. You'll see. Now, inequalities of two variables. Look what we got here. It's the marriage of these two concepts. I didn't know you were going to weigh them. So look at this.
Where's the right?
I don't know what that is. So anyway, we have two variables. It kind of looks like an equation, two variables, except it's not. It's a less than. So what do we mean by a solution to an inequality like this? Well, it's a value that makes it true. So here's a bunch of xy pairs. How can I tell if these are solutions or not? What do you think? What do you think? Plug them in. So 0, 0 is 0 minus 3 times 0 less than 6. What did I just do here? X minus 3y less than 6. Plug it in. 0 is less than 6. True or false? True. That's true, right? So that works. That's a solution. What about 6? So here's the x and the y, right? So x minus 3y. Is that less than 6? Well, what's a negative negative? So that's 6 plus 3, right? So that's 9. Is 9 less than 6?
No.
Something you have to think about it, right? No. So I guess it's not a solution. It doesn't work. 10 minus 3 times 2, is that less than 6? And 10 minus 6, that's 4. Now notice I'm going number to number. Don't stop here. Number to number. True. Okay, solution. Let's try this one. Negative 1 minus 3 times 2, is that less than 6? I'm plugging in. All I'm doing is plugging in. That's negative 1. Negative times positive, that's a negative. And that's a negative 7. That's true.
Yes.
So I've got some that are solutions, some that aren't. So is any ordered pair a solution? No. But there are some that are. How many do you think there are? Can I come up with any others?
Yes.
Yes. Wait, yes. Well, wait, could you just pause on like the origin senses, like you could then do? Oh, wait till you see how we're gonna plot this stuff. The solutions for linear inequalities are very different from just
Should we
equations.
do 0?
What these look like, if you're gonna graph a line, whatever this line is, and I should probably graph that one, but I'm in a rush. So it's going to be a half plane. So these might be all your solutions. A half plane. So it's kind of similar to that idea of a number line. Remember we would look at half a number line? Well, now we're looking at half a plane because we have a whole other variable. Now, remember sometimes this was open? When was it open? When it's not equal to. We have a similar idea with the lines when it's not equal to. So that's what we're going to look at now. So to graph them, you're going to graph what we call the boundary line. And so this is that idea of like the circle that you fill in or the circle you don't. If you have an equal, you use a solid line when you make your boundary line. If it's a less than or greater than, not equal, you're going to use a dashed line. No, that's the idea. It's like having an open circle. You with me? You're going to graph that line. You pick a test point, and that's not on the line, and then we're going to shape. So this is impossible to just read about. Let's do it, okay? So let's just do this thing. On the bottom left, see this example? Everybody's writing this down. Y bigger than 4x minus 3. So you're going to graph the boundary line. How do you graph this? You pretend it's an equal at first. So we have a bunch of different ways. How about slope intercept, right?
Yeah.
So what's M?
4.
And what's B?
3.
Negative 3. How does this work again?
That's the one.
So B is my negative 3, my y-intercepts. I go there first, right? And then this is really 4 over 1, up 4 right one. 1, 2, 3, 4, right one. 1, 2, 3, 4, right one. And now I'm kind of in the way here. I'm just going to erase this a little bit. Anyway. Now, don't draw your line so fast, right? If this was an equation, draw a line. However, now, you look at what you got here.
This is negative.
Is this going to be a solid or a dashed line?
Yes.
Why is it going to be a dashed line? Matthew, why?
Because it's not equal to.
Yeah. And so what does this say? Remember that a graph represents all the solutions? It is saying anything on this line is not a solution. Kind of like when you looked at a number line, how this was not a solution. So anything on this line, not a solution. So where are the solutions? When it was a number line, they were either to the right or to the left. But they're either going to be above or below. That's where all the solutions are going to be. So how do I know? What I do is I pick a test point not on the line. This is important. Yeah, what should we pick?
2, 1.
2, -1? We could. What else could we pick?
0, 0.
0, 0. Why 0, 0? I'm with Noah. I'm looking for easy. Look for easy. You guys like easy. You told me that. So if 0, 0 is not on the line, use that one. If it's on the line, you can't. So pick a different one like 0, 1 or something like that. Pick something easy. So this is the easiest one, because y, you're going to plug it in. Y is bigger than 4x minus 3, is it? So plug that in. 0 bigger than 4 times 0 minus
Yes,
3.
it
And what do
is.
you get? 0 bigger than -3. Is that true or false?
Yes.
And I tell you, sometimes you got to think about it.
True.
So this is a solution, right? This point here. You with me?
Yes.
That means that if I have to shade one side or the other, where should I shade? This one's a solution. So where are the solutions? Over here. And we just make, don't get crazy with your filling in, just the lines like this here. To indicate this, I'm shading this part of the graph, it's like making an arrow. These are where all the solutions live. And what that means is, if you pick any point in the shaded area and you plug it in, you will get a solution, a true statement. If you pick anything not in the shaded area, you will get a false statement, not a solution. What do you think?
So if you when you still got the same thing, but you did it on the other, you did another incident and you did it on the other side, did you get any points for it?
It would work. Awesome. Let's say we picked a test point over here. Now we know this is not a solution. Let's say before we did anything, we said, all right, let's test this one. And this is 1, 2, 3, 4, 0. Let's test 4, 0. So here's my x, here's my y. Y bigger than 4x minus 3. So I plug in a 0, and I plug in a 4, and 0 bigger than 16 minus 3. Is this true? Is 0? No. That means this is not a solution. Don't shade here. Shade the other way. Okay, so when it's true, that means shade there. If your test point is not a solution, don't shade there. Shade the other side. All right, let me see. I think I got some other examples here. Yeah, let's look at this one. What? Wait, Bob, first we got to do the thing. Jillian, don't worry about homework yet. So, graph the point. Uh-oh. Here's a hint. For these, you always want it in slope-intercept form. So what do I need to do here? Solve for y, right? Use the subtraction property of inequality. Now these are inequalities. Same as with you so far. Now do I want negative y? No. Now I want positive y. Multiply by -1. So whenever you multiply, you have to stop and ask a question. Did I just multiply by a negative or am I about to? Yeah. Switch it. This is an inequality. This is the multiplication property of inequality. You've got to turn that symbol. That's a little hard to see. Let me put it up here. Who is with me? Why we had to turn that thing around?
So you're multiplying by a negative
Multiplying
number.
by a negative. So all these rules apply. Now we're going to graph the boundary line. What's the M? M.
Two.
And y-intercept. Okay, let me erase this. There's not a lot of room here. I'm gonna go by twos. So this is gonna be like 2, 4, 6, 8, -2, -4, -6, and 2, right? There's just not enough room on here, so I'll do that. Change my scale. So I want to go to -8. That is down here now. And 2, right? So up to right one? Up to and a half, yeah. Up to and a half. So a little tricky. We're doing it. You get it? Yeah, okay. Now, I have to draw a line. Don't go willy-nilly draw a line. There's a question now. Do I make a solid or do I make a dash? And explain why. Why, Ryan?
So because it is, y is, well, it's
Equal. That means that the points on the line are also solutions. So you make it solid. It's like filling in that circle when you're on that number line. What's this horrible line here? Here it is.
Why would you draw a line?
What? Why is it a solid line?
Yeah.
Because I have an equal. That means that 2x minus y equal 8. These solutions work.
What if it's not greater than or equal to the?
Then you don't. It's like when do you make a hole and when do you fill in the hole? It's that same kind of thinking.
It's
All
just
right.
when there's a line and there's not a line.
Well, sometimes it's a dash line. Meaning the, right? When it's dashed like here, these values on the line, not part of the solution. When it's solid, yes, these points on the line are the solution. Because when you plug it in, you're going to get a true statement because of that equal here. Alrighty, now I have to figure out where do I shade? How do I figure it out? Let's plug in a point, not on the line. So why don't we try an easy point like 0, 0. Plug that in, you get 0 is less than or equal to 2 times 0 minus 8. 0 less than or equal to -8. True or false?
False.
False. False. False. It's false. So is this a solution? So where are my solutions? Other side.
Wait, we still label
I'm just trying to figure out where are the XY pairs that when I plug that in, I get a true statement. They are on the line and they're also in the shaded region. Yes.
So if they're not on one side, it's gonna be on the other.
That's right. It's just like think of your number line. You know how it's either on one side or the other? Same kind of thing. Yeah. This was
Easy.
yeah, this reminder is universally simple. Questions?
On the last one, we did like dotted lines.
Yes. Why did I do dotted lines on this one? This was greater than. So the points on the line are not part of the solution. They're up here only. So this point here, that's on the line, you plug it in, you don't get a true statement. This line is what, 2, 5? So if you plug in that, you get 5 bigger than 4 times 2 minus 3, 5 bigger than 8 minus 3, 5 bigger than 5. True or false? False. So the points on the line are not part of the solution. When you do one of these and you plug it in, you're going to also get equivalence, but that's okay because there's an equal sign here. So yes, these are part of the solution. See what I mean? Yeah, sit with it a little bit. Yeah. Okay. What about this one? Now, yeah, I'm back. So I'm no longer doing a number line. I want this on a coordinate plane like this. It's a Cartesian plane. How do you graph this? Remember, what does y equal -3 look like? Claire?
So you would go, you draw a line on the y -3.
What kind of line? Horizontal. Right? And if you forget, remember what you do? Just put some -3s here, put anything. So 1, -3, 2, right? It's this. Now, okay, great, it's this one. Solid or dashed line?
Solid.
Why solid, Danny? Hey, Danny.
It's greater than or equal to.
Equal. So all these work. Whoops. Because the y value is -3. Is -3 bigger than or equal to -3? Yes. But there are other values too. Let's plug in our friend 0, 0. Well, why is 0 then? Is 0 bigger than -3?
Yes.
Up here. Now wait a second. Does this make sense?
Yeah.
Are all the y's up here that are bigger than -3?
Yeah.
And the down here they're smaller, right?
Yep.
Makes sense.
Yep.
That's the best one. They make sense. What does that look like? What does x equal -1 look like? Then
Vertical line.
vertical line that goes through -1. This, right? Solid or dashed? Solid or dashed?
Dash.
Less than. It is -1, less than -1, not a solution. So I put my dash lines where x equals -1. I will say this, sometimes it's hard to tell. You might want to, especially if you're turning something into me, just tell me this is a dash line. Sometimes it's a little hard to tell. But put a little note there so I know. Where is x less than -1? Left side or right side? Left side. Don't even have to put it in. So these ones we should be able to see. Who gets this so far? Like, okay, following. Your hand's not up, I'm worried a little bit. Have a question. That means we're ready for this. There's another way to determine how to shape. Keep this plug it in a point though. There's nothing wrong with it. Okay, you're going to isolate y. You always want them to be in y form. Okay? If you have a less than involved, you're shading below. Less than means below. And if you have a greater than involved, shade above. Less than below, greater than above. Vertical lines, you can see it, right? If it's an x, you go left. If it's a greater, you go right. Yeah, we saw those. So let's do this guy here. First, I have to isolate for y. Subtraction property of inequality says that this would be my next step. Division property of equality says I can divide by 2. Do I change the symbol?
No.
Why not?
It's non-negative.
Dividing by positive everything, right? So y bigger than -2x plus 3. You're with me?
Yes.
So I have to graph this guy. So m equals and b equals. So I go to my b of 3. -2/1 says go down and right. Okay. Down and right. Down and right. Down and right. Or up and left. Now I have to draw this line, but before I do it, will it be solid or dashed?
Dashed.
Dashed. Because this part of the line is not a solution. And because sometimes it's hard to tell, you might want to get into this habit. Just put a little note, especially if you're handing something in to me, I know what you mean. Okay. Now, we could use a test point. There's absolutely nothing wrong with using a test point. But if you want to kind of really think about this is a greater than sign, right? Do we shade above or below? Greater than is above. What does that mean? Where's above? This part, this above. Yeah, now I'm above the line. Yeah, let's plug it in too, make sure. Let's try 0, 0. I'm expecting it not to work. Now put it back up here. 4 times 0 plus 2 times 0. Is that bigger than 6? Well, that's 0. No.
Oh,
So-
you do with the original one?
Yeah, I would do it for that, just to make sure.
Can you do it with the white?
You could go here, but I'm just saying, this one, in case I mess this up, this one is better. But you see, you can just stay above. What about over here? Whoops. Okay, come back. Word problem. Okay, word problem. These aren't on here, are they?
Nope.
Oh, good, okay. Okay, you have 2 summer jobs at a youth center. You earn $8 an hour teaching basketball, $10 an hour teaching swimming. Okay, let X represent the amount of time you teach basketball. So let X is time for basketball. And we're going to let Y be the amount of time in hours for swimming. So you want to make at least $200 a week? Huh. So let's see. 8X, right? That's because it's $8 for basketball. Plus $10 for swimming. I want it to be at least 200.
That's gonna be less than.
200 or greater.
Which is it? He said less, you say greater. If you want to make at least, are you okay with 150?
Greater.
So you want to be at least greater than or equal to that. else do we know? Huh. I need another, no, I don't need another. Okay, we're good. There's my inequality. And then you're gonna graph this. Oh, so, let's see. 10y bigger than or equal to negative 8x plus 200. That's the subtraction property equality. Divide by 10. Do I turn the symbol?
No.
So that's negative 8 over 10. Negative 4 over 5. Plus 20. Eesh. 2, 4, I'm going to have to do this, I don't know, about 5s, I guess. 5, 10, 15, 20. 5, 10, 15, 20. So, let's see, 20 is my y-intercept. I go down 4 and right 5. Down 4, right 5, down 4. I think I'm doing that right. Okay, now, is it going to be solid or dashed? Now, it says here, think about domain. Why do I just go like here?
Domain's only on numbers.
What?
Domain's only on numbers.
Is it? Can I work less than,
Oh, never mind.
yeah, right, so we want positives. Which way do I shade here? Yeah. Which way do I shade? Here's a greater than, above or below?
Above.
So if he wants to figure out hours, you could just pick what are 3 points that will be the hours. So he could work 15 hours with the basketball and 10 hours with the swimming, and he'll be more than $200. Or he could do 10 hours in basketball, and this one is what? 20 hours in swimming, he'll be above. Yeah. Right above, right here. Here. So does that work? Say that's 25 and 0, plug it in. Now remember, this is extended, and so this is all part of it. All right, so that's a word problem. We can do this. All right. This is kind of an advanced topic. You guys are up for it, I know it. Writing inequalities for graphs. We haven't really learned how to write equations, but you can see how simple it is. I want to write this inequality. What does that even look like? So, yeah, you know already?
Yeah.
Well, how do you do this?
You,
It tells you what to do. Find the slope and find the y-intercept. We'll find the y-intercept. What's that?
the y-intercept is 2.
So that's b, right?
Yeah.
And then what's my slope? Remember how to find slope? Have 2 points. Let's see, I go up how many? 2, up 2. And then I go right 1, 2, 3, 4. So what's that, a half? My slope is a half. You have to go with 2 points on the line. You could have gone here. You get up 1, right 2. There's your half. And there's 2 points on the line. Are you watching?
I went over 2.
We want to find that the y-intercept and the slope. To find slope, take 2 points on the line. You could put that in the formula, right? Or you can count boxes. If I go up 1, that's a positive 1. I go right 2, that's a positive 2. You can pick 2 points here, but you may have to reduce. Are we okay with this slope and this y-intercept?
Yes.
Y equals mx plus b, right?
Yeah.
So if we just want the line, what is that equation? M is a half, B is 2. We just put it back in. That's the equation of this line. Now wait a second. It's inequality, right? There's shading up here. So I don't have to figure out what the inequality is going to be. Now, is it solid or dashed here? So is there going to be an equal? No. Is this line above or below?
Below.
So, where's your right here? This is dashed. Okay. So what goes here? A greater than or a less than? Above is greater than. Equation, the inequality's right. So you can go backwards. Yeah, you can do that. And I think I'm going to try. Yeah. So I want you to try some of this graphic. So this one was a little tricky because it's more than nice integers. So you subtract that of x using the subtraction property of inequality. And then we divide by 3 using the division property of inequality. Because this is a positive number, I leave my sign the same. And so what is that? That's a negative 1/3 x minus 1/3? Okay, so it's a little tricky. Your slope is negative 1/3 and so is your y-intercept. All right. So 1/3 is about here, right? Negative 1/3. So this says either go down one, right one. So down one, right three rather. 1, 2, 3. Or up one, left three. So up 1, 1, 2. Something like this, right? Do I make a solid or dashed line here?
Solid.
Solid because equal, so these are all part of the solution to this inequality. And then I have to decide, do I shade above or below? Above. This is above. What was the other way to figure out where you shade? Pick a test point. If 0, 0 is not on the line, try it. So I'm going to just plug it over here. So that says 0 bigger than negative 1. Is 0, 0 a solution? 0 bigger than negative 1? Yes. Yes. Cool. Done. All right, some of us have finished this whole thing. So I thought I just put it up there. What do you think? This is 2, right? So look at that stuff. This one is 2y is less than negative x, right? And y is less than negative half x. So your m is negative half, and your b is 0. So down one, what? And this one, well, you don't got that, just convert the horizontal, and you shade up. Questions? Comments? Well, this is where it's going to show. If your graphing skills are good, this will go well. If your graphing skills are still a little shaky, use this as an opportunity to get them good. All right. Questions? Any other questions? I think my last chart here is just a summary. XY pairs that make the inequality true. Graph. Use a solid line if it's an equal condition. Otherwise, use dashed. Pick a test point. Or shade above or below. So just leave me back on here if you guys want to see this. And that is graphing.